First up, we want to find the logarithm of 378. Now notice there's no base here, so really just kind of read into it. You don't need to write this. This is really the log base 10 of 378. So on my calculator, this is going to be a calculator problem because what I'm looking for is this an exponent? What exponent would you put on 10 to get you to 378? So you're looking for this. What exponent would you put on 10 to get you to 378? Well, let's see. We know a couple things. You know it's not 10 to the first. That's only equal to 10. You know it's not 10 to the second. That's 100. And you know it's not 10 third because that's 1,000. So where are we? At 378, we're somewhere between 2 and 3. So the number we're looking for in here, where the log of 378 is somewhere between 2 and 3, and that's the number we're not going to be able to guess. So we go to the calculator. So I'm going to type the log. I get a parentheses, and then I'm going to type 378 and close it, and what comes up is this number here, 2.5774918. That's what's on my display, but I want to round to 4 decimal places, so let's count them. 1, 2, 3, 4. All right, that's a 9. It's bigger than 5, so I'm going to round that up to a 5. So I'm thinking 2.5778. So what we're saying then, I'll do it right up here at the top, that the log, I'll write the base 10 of 378 is about 2.5778, which means the logarithm is the exponent. This is the exponent that you would put on 10, 2.5778, to get you to 378. Right now, that's really not going to get you right there. It's going to be really close because we rounded off. And then sure enough, that here it is, at 2.5778, that is right between 2 and 3. So we're probably good. Let's take a look at another feature of this problem before we go to the next. Here's a picture of the log function. It's a curve that increases at a decreasing rate like this, and the logarithm of 1 is 0. Here's our x-axis and our y-axis. And we've talked about this in the last section, that if you take the log of a number bigger than 1, right out here, that look at where the curve is. It's above the x-axis, so you get a positive number. So we're out here. This is not the scale. We're out here at 378. If you take the log of a number bigger than 1, like 378, you're up here at a positive number. And sure enough, when I saw this back over here, right at the beginning, the log of 378, I was expecting a positive number because I know what the graph looks like. Number 7, we're taking the log of this small number. Right now, this number is between 0 and 1. So if you look at our graph down here, what are we expecting? Here's that number. We're expecting a negative number. So this log should be, I'm going to write it here and we'll come out and find what it is in just a minute, but that should be some kind of a negative number. Now what does this say? It's log with no base on it, so we know that that base is 10. So really what we're looking at is this. The log base 10 of 0.0378 is some number, and what number this is, all right, we're going to put this exponent here on 10, right, so we're thinking, okay, 10 to what number is going to give us 0.0378? Well, it's a calculator problem, so we're going to type in log, just the common log, and then we'll type in, I think you get a parentheses when you do it, type in 0.0378, close the parentheses, and I'm getting negative 1.42258082 on my display, but I ran around to I'm going to round to 4 digits, 4 decimal digits, 1, 2, 3, 4, that's a 5, so I'll raise that, no, 1, 2, 3, 4. Okay, that's a 0, so I'm just going to drop everything else and keep the 5. So I'm going to write this as negative 1.4225. So to summarize, back here, negative number, right? It's a negative number. It's not what we were expecting. So I'm going to claim this as negative 1.4225, which means that if you take 10, try it on your calculator, 10 and raise it to the negative 1.4225, you're going to get a number real close. In fact, why don't we just say this? This is approximately equal to 0.0378.